Hi everyone, welcome to this lesson. So in this lesson today, we'll be looking at bridging the gap and moving AI from POC to production. So this is chapter 10 of the book, Multi-Agent Orchestration Pattern for Enterprise Scale System. So, all we've been discussing in the book is how to design multi-agent system, how to design the orchestration layer. And we've discussed the type of orchestration we have. We've discussed the central orchestration, the hybrid orchestration, the, manager worker orchestration, and what have you. We discussed communication pattern in multi-agent system using PubSub, Kafka, RabbitMQ, and the like. We looked at observability and metric. We look at how you should design your agent with task ID, correlation ID, and what have you. So this is the last part of the book, multi-agent system. And in this lesson, we'll be looking at POC, from POC to production. How can you move your agent from POC to production? So that is all we have here. So at the end of this lesson, you should be able to, design a multi-agent system from beginning to the end. You should be able to deploy it, and you should be able to monitor it and architect multi-agent system. So if you read the book from the beginning to the end, what you'll be able to do is actually architect a multi-agent system. All right, so in this our first page of the slide, we have surviving the production reality gap. So how can your agent survive after production? How do you monitor the agent after deployment? How do you observe? How do you collect metric? What do you want to measure? So how do you maintain or manage the multi-agent system? So that's what we are looking at here. So surviving the production reality gap. Experimental success does not guarantee operational stability without methodical implementation discipline. So if you just deploy an agent into production and just leave it there, it doesn't guarantee that the agent is successful. It doesn't guarantee that the agent will, generate the output or the required output that the business users want it to give. You are not developing agent for yourself. You are developing for business owners and business users, who are the ones that will actually give you feedback whether the agent is doing what it's supposed or designed to do or not. So this is how you can measure the production reality gap. Number one, data quality. So real world incidents are noisier than test set. So when you expose your agent to the real world application, what is the quality of the data you are getting? Are you getting the kind of output you are supposed to get from the agent? Or does the output make sense? Does the data make sense? Or does it generate, or does it measure the required metric or the business KPI? So that is how you can also measure your agent. Then we have number two, integration friction. Legacy system fields service, e.g. service now, ERP, like SAP applications are often inconsistent. So most of the time you can use a version of AP, you can use a version of API, it can expire, the API can change, the platform can be renewed, and so on and so forth. So you need to measure your integration very well. You need to monitor your integration or check them often after deployment. Then organizational conflicts. So classification that work in a lab may trigger departmental disagreement in reality. So this is like what I've said before. When you deploy multi-agent system into production, you have to get feedback from the business owners, get feedback from the CEOs, the CFOs, all the people involved in the multi-agent system design, all the stakeholders. Make sure you get feedback and make sure the feedback is excellent. If the feedback is not excellent, then the system must be redesigned. Then we have operational rigor. So deployment require methodical engineering, not just innovation prompting. So you must put every form of operation into practice. Observability is very, very important after deployment. You just set the alert. No, when you set the alert, you must make sure that you collect metrics, and you must make sure you analyze the metric to know how the agent is functioning. This is why we said that when you are designing multi-agent system, make sure you design 2 user interfaces, one for the business owners and one for observability. Very, very important. You have to collect the metrics and visualize the metric, know how each agent are performing individually. Slide 2, 8th dimension. So 8th dimension of post-production maintenance. So strategic selection criteria to prevent technical debt and irreversible architectural lock-in. So how do you prevent irreversible architectural lock-in after deploying multi-agent system into production? So I've collected these dimensions with their key criterion and evidence that is required for their checklist. The first one is orchestration. So for orchestration, you use checkpoint base. So checkpoint recovery. So if you want to, or selection criteria for technical depth. So to measure the technical depth of orchestration, the orchestration layer of the agent, what you use is checkpoint-based recovery. Okay, so that is kill process at step 3, verify restart from preserved context. So if the orchestration layer stopped working, you must verify how it's going to restart. You must collect the metric, and you must also implement a checkpoint on the orchestration layer. Then the next one is the integration layer. So to to measure the technical depth of integration layer, you set secret management. That is, make sure all APIs are stored in key vault. Make sure every access to the integration layer, every access to the business databases, ERP system, and so on and so forth, are stored in key vault. You must not deploy secrets or production or business API, business application APIs into production. Make sure they are stored and managed in secret or key vaults. So verify no plain text credential in platform configuration. Always verify that no secret is exposed, no API key is exposed to your production or your repository. Then the next one is scalability. So to make sure your multi-agent system is always available, make sure you deploy to multi-region. Use multi-region deployment. For example, if you are deploying to cloud, you are using one of maybe UK South, you can use another one in maybe UK West or wherever. So just make sure you use multi-region deployment, and confirm data residency. So before you use multi-region deployment, make sure you do your RACI, confirmation. Check data residency. It's very, very important. Check whether it is allowed to store your country or your company data in the particular region that you want to deploy in. For example, in Nigeria now, Central Bank of Nigeria has said that all financial transaction data in Nigeria must be stored in Nigeria. So if somebody is building a multi-agent system for a bank in Nigeria, and you are hosting the database in UK South, for instance, it is wrong. It is legally wrong, and you can be arrested, or the company can be arrested if they find out. So security. So type 2 audit log. So implement security. So type 2 audit log. It's very, very important. Least privilege, minimization, anonymization, role-based access control. Very, very important. So give the agent access to the information that they need. Do not give the agent access to all the information in the database. Give the agent access to the only tools, the only data that is required for the operation. So verify append-only logs with cryptographic chaining. Maturity. Use distributed tracing to measure the maturity of the agent, and you can use this Jaeger tool. So trace single request across 5+ agents through completion. Then we have viability, vendor financial stability. So always check the vendor financial stability. Can the company afford it? If they cannot afford it, so why build it? So check if the company can afford it even before you design the architecture. So always review runway 24 months, check the cost, measure the cost 24 months ahead, and measure the ROI, return on investment, and ARR trajectory. Total cost. So measure year one total cost of ownership and model it. Check how it will grow. So if you can forecast the total cost of ownership for year one, you can extend it to year two, and then you can use that to determine the return of investment. Are the company, generating profit or loss from deploying the agent? So model cost at 1 times, 5 times, or 10 times projected volume. Then DevX, so development explainability. So time to first working agent, and measure time for new development to build agent using docs alone. So these are some of the technical depths that you can put into consideration when you are designing multi-agent system. So in 2025, of course, we know that choosing between managed cloud, convenience, open source flexibility, and enterprise grade is very, very important. So if the company can afford a cloud platform, so it is better to deploy in the cloud. If they cannot afford it, if maybe because of data residency, they can implement hybrid approach. Some of the agents can be deployed on-prem and some on the cloud. So enterprise vendors is very, very important. You can use like Azure, like AWS or Google. Then if there is compute, on-prem compute, where everything can be hosted, you can also go with open source end-to-end. And then if the company has the capability and there is no data residency limitation, then they can go for managed cloud, everything on cloud. Adopting a prompt-first development discipline. So you remember when you are designing generative AI, for instance, the first thing is to get your base model, which is your LLM, which can be GPT-4.0, for instance, and then you put in prompts. So you put some prompt information on how it should behave, what you want it to do. So you just control the brain of the model, and then if prompt is not enough, you can implement RAG database, use where you have the company data being chunked, ingested, embedded, and chunked, and store in vector database base and retrieve to augment the information that is being generated from the LLM. And then if RAG and prompt is not enough, then you can then fine tune with some specific data set, and then evaluate the outcome of the fine tuning. So implement prompt first development discipline. So always start with prompts whenever you are building a agentic AI system. So you can use semantic fashioning where prompt follow major minor patch logic. You can use integrity check where content hashes detect if a prompt was modified outside the approved process. You can also use environment progression where prompt move from development to staging to production. Promotion requires pass test or maybe on pull request and so on and so forth. Remember, it is said that you should treat agent prompt as code. So always make sure you implement CI/CD for prompts, pass your prompts through development, staging, and production. And whenever the business requirements changes, you know that the prompt must also change along with it. So incident response, dedicated rollback paths allow for sub 5-minute reversion during production. So treat your agent prompt as first class code artifact with rigorous functioning and testing. Make sure you pass the prompt to development, staging where you test the prompt and before you move it to production. So standardizing enterprise agent architecture. So how do you standardize enterprise agent architecture. Remember, when you are standardizing architecture, you must also standardize the data. So check the input schema, validate validate fields at the boundary to catch orchestrator bug and prompt injection. Always make sure you implement guardrails to prevent against prompt injection and unnecessary data drift or bugs or any attack from external factor on the agent or on the API. So validate the input schema to ensure it enters or it is in the required format. Then injection sanitization, automatically wrap external content with traits as data, not instruction delimiters. So injection must be sanitized. Everything coming into the agentic system environment must be sanitized through predefined guardrail before it is passed onto the system. Confidence scoring. Every output must include confidence field. Missing score default to 0.0 and trigger escalation. So set confidence for every output coming from the agent into the database, and then default is 0.0, and when it is 0. When it's default to 0.0, then an alert is triggered. That means something is wrong. So audit summaries, standardized logging of execution duration, confidence, and rationales, for observability or for metric and alerting. So audit log is very, very important for governance and, observability of the agentic system. So always make sure you enforce consistency across distributed agent teams through strict schemas. Multi-layer testing strategy. So how do you test your agents? You are developing multi-agent system, so you should always also test the individual agent. Test agent 1, agent 2, agent 3. Also test the orchestration layer. Verify probabilistic behavior across golden set, adversarial attacks, and chaos engineering. So agents are probabilistic in nature because you are using prompts to to build the model or to train the model. So there is a probability that the agent will not do what it's designed to do because they are probabilistic model. Anything built on LLM is probabilistic in nature. So multi-layer testing must be implemented. You cannot use the test that you designed for agent A to test agent B. Why? Because the function of agent A is different from agent B, and the prompt you put into agent A is different from the prompts that you develop for agent B. So each agent must have their own test layer. So we have golden sets, known correct pairs, 100% pass rate, require high stakes cases. Integration layer, also test the integration layer. Verify agent A output matches agent B expected input schema. Then also test adversarial test. Attempt to manipulate the agent via prompt injection in data. So that is chaos engineering is intentionally, chaos engineering is just the process of intentionally disrupting your system to check whether the system can withstand failure whenever there is external injection or external trouble. So you just intentionally subject the system into disruption to test whether the system is reliable. That is chaos engineering. So you can also do the same thing for your agent. Intentionally inject adversarial data or corrupt data into the system and see how the system will behave in the face of this kind of injection. Edge case coverage, testing malform or incomplete inputs such as missing vendor country. So also check the edge cases. If you are developing agents, and part of the agent is deployed in UK South and part is deployed in, let's say, US East, for instance, you may want to check test for edge cases, whether data coming from UK South align with data coming from East US. Operationalizing site reliability engineering for AI agent. So always make sure you measure particular metrics, which is SLOs, SLIs, and um, bugs. Define a service level objective that account for both system availability and output quality. Very, very important. So we have this tabular explanation: service availability target, quality target, escalation SLA. So compliance screening. So the target score for compliance screening of the multi-agent system should not be less than 99.9%. So quality targets should be 97.0% accuracy, and escalation 1 hour email review should require. Legal contract review 99.5% availability target, 90% accuracy target for quality, and 8-hour email review. It's escalation SLE, so it should be escalated uh when it has 8-hour email review. IT incident classifier 99%, 99.9% availability, 85.0% accuracy for quality target, and escalation should be done immediately for P1 when you have a at 10%. Should be escalated. Vendor analysis 99.5% availability, 88.0% accuracy, and 48-hour email review. So escalation should be done when it has 48 hours email review. You can see how the availability, quality, and escalation are measured when for specific multi-agent system because of their domain expertise. Optimizing cost across the 5-tier stack. So strategic management of LLM token consumption to prevent pricing cliffs at scale. So you must make sure you monitor the cost of LLM tokens. Very, 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 very important, because that is where the majority of the money will go to. So make sure LLM tokens are not being wasted whenever there is no operation. So make sure this is measured continuously to reduce the cost of LLM usage. So routing, use a 0.000 model for tri-age, reserve GPT 4.0 or Claude 3.5 Sonnet for complex reasoning. So I think I've seen the implementation of this in like Copilot here, Copilot Studio, under the research capability of Copilot Studio. So if you want to do a small task that the Copilot can do, you just use the research. Then if you want to go a little bit deeper, you can choose GPT. Then if you want a thorough research, and then you can just switch it to Claude. So that's what I learned from there. So also when you are designing multi-agent system, use this process. Use small models, or use small models for small tasks. Use medium models for medium tasks, and use higher models for complex tasks that involve complex reasoning. Semantic catching. Catch similar input pattern to eliminate 30 to 40% of repeat calls. So always implement catching so that the agent can have immediate access to, any operation, that is paused, or to what it is doing at the moment. Batch processing. Use batch API for non-real-time workload to secure 50% discount. So if the process is not real-time based, then you can't continue calling the API every minute or every second. You can implement batch processing. Maybe the agent can call the API, the database API, every 8 a.m. in the morning. And when it call it and get information from in the 8 a.m. in the morning, the first day, then it's to trigger again the call again 8 a.m. the second day. So this will also help you reduce the cost of LLM token usage. Budget monitoring, real-time alerting when daily spend hits 80% of the configured agent budget. So always set threshold. So what you can do is set threshold for each agent, so that when a budget reaches or hits a particular percentage, an alert should be triggered, and then you can monitor the operation, what is happening, what has gone wrong, then you can reset the token usage for the LLM, or go for a lower LLM that will generate less cost. Multidisciplinary team. So remember, to build multi-agent system in an enterprise, you need more than agentic AI engineer or generative AI engineer. Okay, so you need, first of all, you need the domain experts or the business owners, because they are the one that will use the agents. They are the one that own the business, they own the data, they own the metrics and the KPI. And when you deploy into production, they are still the one that will use whatever data is generating. They own the process, okay? They own the everything. Yours own operation is just to deploy and hand over to them. So you have the business owners, for instance, and then you have the security engineers, which will implement policy and governance. You have the operation engineers, which are responsible for monitoring and observability, production, deployment. You also have the agentic engineer that will develop the agents, and you have the data engineer that will build the RAG database and make the data available. You have the integration engineer that will integrate the multi-agent system to business layers like ERP, SAP application app, and enterprise applications. So you need agent engineers who focus on prompt engineering, structured output, and regression testing. Of course, these prompts are business information, business requirement turned into technical information. You understand? So platform and site reliability engineers. So these are the people that will manage Kubernetes, CI/CD, and error budget enforcement. Then you have domain experts, so who will provide the golden set example and review sample outputs, and they are the one that will give feedback whether the agentic system is functional or not. Then you need the cultural rituals. So implement blameless postmortems for quality failures and weekly production reviews. So these are the, we call them COEs, Center of Excellence, Agentic AI Center of Excellence. So they are the one that will sit and discuss whether this agent meets requirements or not. So, and this is the production implementation architecture. So, and it follow best practice. So you can see it is numbered 1 to 6. We have the strategy and design, which is when you get the requirements, the business usage, the business problem from the business owners, then you convert it to technical information or technical objects, and then you design the architecture. So you have the strategy and design. This happens when you have gotten the requirement from the business owner. So you have your platform, evaluate the platform, design the architecture, design and review the architecture with the business owners, and then develop the prompts from the business requirements. 2, we have the build layer. After you've evaluated the platform, design the architecture, and review with the business owner, and it is accepted. The next thing is to, develop the prompts. Remember, treat your prompt as code. After developing the prompts, then you start building the agent, build the orchestrator engine, build each agent, the number of agents that you have there, agent development standards, prompt fashioning, start fashioning your prompts based on each agent. Then after building, then you design integration. So that means you have to determine where you are connecting to, all the business or platform that you want to connect to. Then you now start connecting. Quality assurance. So this quality assurance is just like the staging layer where the agent is tested whether it meets the company standard or the design standard for the organization. So you have the golden test, you have the regression test, adversarial test, whether it can withstand prompt injection, integration test, whether it can successfully connect or integrate with enterprise applications. Then we have the load and chaos testing. And then number 4, we have the delivery pipeline. So that is the staging layer. Number 3 is the staging layer. Number 4, we have the delivery pipeline where you implement CI/CD. Make sure all your agents go through gated pull requests development to number 2 is build layer. Number 3 is staging layer where you test. And number 4 is production. So where you implement your CI/CD pipeline, do security scan and staging. Then we have our production release. So that's final release. So always use this method, canary deployment or rollout production. You can use canary deployment or you can use rollout, gradual rollout, and then roll back when it does not make a complex standard. Then number 6, we have runtime operations. So service level objective, define your observability, configure your alerts, collect metrics, and visualize. Visualize the metric on the dashboard to see the performance and so that you can observe how each individual agent is behaving. So you can measure the SLOs, measure the cost, token cost, LLM usage, observe every metric that you have defined, and also measure the post-mortem after deployment. How is the behavior of the agentic system in general? Then your production mindset should be treat your prompt as code, very important. Test beyond the happy part, release with canary and rollback. Very, very important. So, and implement continuous feedback loop. So you don't just deploy and leave it. When it is deployed into the system, get feedback from the users, from business users or from business owners or from the agentic system center of excellence, and then work on the feedback. So saver release, higher quality, controlled cost, and continuous improvement is the standard for designing the architecture of multi-agent system. And this is the end of this lesson, guys. So the book is available on Amazon. I have dropped the link in the remaining videos. Please do well to buy, and also check our website for consulting, data engineering, agentic system engineering, and machine learning, and generative AI and cloud implementation. Okay. Thank you for listening. See you in the next video. Bye.